Hi everyone and welcome to AXA Arctic Live. It's fantastic to have you all with us. We have schools from the UK, USA, Canada, Bermuda, Ireland and Spain with us. And if you have sent in a shout out, those will appear as a scroll at the bottom of the screen. Really looking forward to this lesson all about sea level rise and ice. And it's based around an activity which we'll get to shortly. Just before we get into the lesson, a few points of admin. You'll have seen that if you're on the Encounter EDU website, to the side of the screen is the chat app. That's where you can post your questions. That is also where we will show a poll for you to answer as a class before the activity starts. Now, if you want to have the screen full screen, the video full screen, you can do that by clicking on the full screen button on the player. But if you also want to see the question and answers, upvote, that kind of thing, you can always view the lesson on a secondary device, such as a smartphone or tablet. Now, if you're posting questions, you can do that anonymously, but we're also delighted if you include school or class names there, just so we can name check those when we reply to the questions. If you do have any technical difficulties during the live lesson, please click on the speech bubble at the bottom right-hand corner of every page on the Encounter EDU website, and a member of the support team will be with you shortly to help you navigate any of those issues. But without further ado, it's my great pleasure to get on with talking and investigating sea level rise in the polar regions. We're going to start off by introducing a little bit about where we are normally based up in the Arctic for Arctic Live, then some background on ice and the different types of ice that you may or may not encounter if you were to come up to the Arctic or indeed go down to the Antarctic. We're then going to set up a little demonstration activity, little investigation. Do follow along in the classroom as well. While that takes time to work its way through, because it's looking at melting ice, we will then come to the Q&A and look at the results later on towards the end of the live lesson. So when we are in the Arctic, we have a wonderful base up on the island of Svalbard, and that is halfway between the north of Norway and the North Pole. It's a fantastic place, the interior full of mountains and peaks and glaciers. And then we are situated in the international science village of Ny-Ålesund. Now, Ny-Ålesund is composed of a range of different national research stations. So there's from Norway, France, Germany, the Netherlands, Italy, the UK, of course, and then Korea, Japan, China, and India. There's also shared facilities such as research vessels, so we can go out on the fjord, do our research on the ocean, and also use skidoos to get up onto the glacier and research some of the changing Arctic environment on land as well as on sea. There's also atmospheric research being carried out, some absolutely bonkers stuff. There's some radio telescopes that measure particles that set off on their journey before the Earth existed, which is quite a thing to get your head around sometimes. But one of the defining features of Ny-Ålesund, the area, Svalbard, and the polar regions in general is ice. Now, we have the Arctic at the north of the world, north of the planet, and then we have the Antarctic at the southern extremes in the southern polar regions. That's the Antarctic. And perhaps the Antarctic is most familiar, and because it's a continent in its own right. And this is a satellite image of the Antarctic continent without any real that much sea ice being shown. Antarctica is a continent surrounded by ocean. In fact, the Southern Ocean, the ocean that runs around the continent, has just been recognized by the National Geographic Society as an ocean in its own right. But the continent itself is about 14 million square kilometers. That's about 2 Australias, if you want a comparison. And it contains a huge amount of ice. At its thickest point, the ice on Antarctica is 5 kilometers, or 4.5 kilometers thick, average about 2 kilometers thick, and it contains an extraordinary 30 million cubic kilometers of ice. Now, that is 90% of all ice on the planet, 70% of it's fresh water. But the interesting thing about Antarctica is not just that ice on land, it is also the ice that grows in the sea during the winter. And I think we can see an image here where you can see that there's about 7 million square kilometers of sea ice around the continent forming in the dark months, in the austral winter, so that's summer if you're in the northern hemisphere, in the UK, Europe, North America. And that forms on an annual basis. So you can see the full extent there, 7.2 million square kilometers, shrinking down to 1.1 million square kilometers during the austral summer, the winter months in the northern hemisphere. And that's an annual change. During the cold of winter, it's small, then coming out. Sorry, it's cold of winter in the northern hemisphere, cold of winter in the southern hemisphere. I'm getting my austral and summers and winters confused. So to start again, when it's cold and dark, you've got lots of sea ice, and when it's warmer, you've got less sea ice. If we just come up to the Arctic, we will see that the process is similar. Now, the Arctic is slightly different to the Antarctic. It's an ocean surrounded by different land masses. So you can see on this image, bottom left-hand corner, you have Alaska, part of the USA. Then you have Russia reaching round, coming round to like top of the clock, 12 o'clock, and then round to like 1 o'clock, 2 o'clock. You have Scandinavia, so Finland, Sweden, Norway. You might just see Iceland peaking out at 3 o'clock, and then round to 4 o'clock, Greenland, part of the Kingdom of Denmark, and then round the rest, you have Canada. So you have all these different land masses around the Arctic Ocean. What you can see here is a satellite image of the Arctic in summer. You can see that there is about 2.5 million square kilometers of ice out of a total Arctic Ocean area of 14 million square kilometers. Don't worry about these numbers. I'm memorizing all these numbers. They just give you a comparison figure. So you can pretty well drop the continent of Antarctica into the Arctic Ocean and be roughly the same size. Now, just like the Antarctic, we see that amount of sea ice expand during the winter months and then contract during the summer months. Easier with the northern hemisphere because the Arctic's got the same summer and winter as us. So that changes from about 2.5 million kilometers square in the summer, then grows out to about 6 million square kilometers in the winter. So expanding like double, triple the amount of sea ice on a seasonal basis. Now, with the changes that are happening on the planet, we're seeing the minimums in the summer get smaller and the maximums in the winter also slightly smaller. What we're going to look at during this lesson is a variety of different types of ice. I just want to go over those. Now, the first one we have is land ice. Okay, so land ice is ice that's formed on land by falling snow, then compacted into ice, and can comprise ice sheets like we saw over the continent of Antarctica. Also over Greenland, you can see that even though the sort of sea ice levels change, that Greenland has that ice sheet there. The Greenland ice sheet also hugely thick, at thickest point about 3 kilometers. So that's land ice. Now, when that land ice meets the sea, it can break off or carve into icebergs. So icebergs are bits of ice formed on land that break off into the sea. Now, we're going to compare that to sea ice. Now, sea ice, as we've looked at the expansion and contraction of the white areas around Antarctica in that second image, and then in the Arctic Ocean in those third and fourth images, that is formed when the sea freezes. And because it's salty, the sea does not freeze at 0 degrees Celsius. It in fact freezes at about minus 1.6, between minus 1.6 and minus 1.8 degrees Celsius. And today, what we're going to look at is how these different types of ice, when they melt, affect sea level rise. So you're going to need a few things for this activity. I'm just going to reach over and get them. You're going to need 2 plastic boxes to act as your mini oceans. You're going to need some cans to stack up to act as your land masses. You're going to need some water, of course, to be in your ocean. Of course, you're going to need some ice. I've got some bits of ice here. Don't drop them on any electronics, but some ice. And then we just need a marker pen, and we're going to use our marker pen to measure the sea level and then see how it changes over the course of the live lesson. So I'm just going to set up my first land mass and everything else. I'm going to put some water in first. And then I am going to balance, move this ice closer so I don't spill it too much. And it's going to balance some bits of ice on top of my landmass. That's about 4 bits of ice there, 5, 6, 7, and then 8 on the side, and maybe get 9 on top. Okay, I'm just going to put this down carefully. There we go. And then with a marker pen, just mark on here the level of our ocean. And what I'm going to do is I'm going to put it, in fact, in the sun, just over the other side of the studio. And we'll see what happens. I'm going to move this one away, and we'll set up the second one, which will have sea ice rather than land-based ice. So put this there. I think we had 9 pieces of ice in the last one, so I'm just going to add 9 pieces of ice into our ocean here. 1, 7. So I'm just, there's sort of smaller bits at the bottom here. 8, 9. There we go. I'm just going to mark the sea level here. We're going to predict what will happen to the sea level in each of these. So in this one, we have all the ice in the sea, so like sea ice, and the other one, we have the ice on land. So there's a poll that you should be able to see in the chat app, and that gives you 4 options, okay? It gives you the option of the sea level will remain the same for both. Only the land ice sea level will rise. Only the sea ice sea level will rise, so that's this one here. Or the sea level will rise for both. Now, we've got a few short clips of us in action working in the Arctic on our science while I go and move these to a place in the sun to accelerate the melt. If you need to move your mini oceans too, if you do have them group by group, or you're working in groups in the classroom, you can always write your names on the side of the containers too, if you're putting them somewhere slightly warmer, so that we can observe any change by the end of this live lesson. Brilliant. I could see some of those predictions come in, so we'll have a look at those just before we observe what changes have happened, and we will see whether your predictions were correct or not. We've got some great questions through, and I can see them coming up here. I'm going to take them in voted order. So if you've been voting and upvoting your favorite questions, that is absolutely fantastic. The first question is from St. John's Primary. And the question is, how much has the landscape changed while you've been at the research space? It's an absolutely brilliant question there. It's difficult for me to say because I've been going at a slightly different time each year. But so I've been up in March, April, and then in May. So it's been a little bit different. Two of the things that surprised me, one of which was I was up in there in sort of mid-March in 2016 or 2017, and it was raining and 2 degrees. So raining and 2 degrees during the Arctic night in March, which was pretty surprising. And the other thing was that the melt, so the change from sort of spring to summer, seems to be coming about a week earlier. For those who have been working in Ireland for longer, for sort of decades longer, they've really noticed it. In fact, you can see the image of the fjord behind me, the sea inlet that comes past the station. That used to freeze solid in the winter and doesn't do so anymore. And also there's an island which if you looked out, it would be sort of in this direction. And people thought it was part of the mainland, but the glacier connecting it to the mainland has completely retreated. And that's just in the past decade. So really, really great question there. How is it affecting the animals that live there? And I think that's probably a question about sea level rise, and that's from Parsons Green Prep. Really great question. I don't think it's so much sea level rise affecting animals in the Arctic. There are issues with ice, and I'll come to that quick in just a bit. There is evidence that sea level rise is affecting animals in the sea, in the ocean, and other parts of the world, such as coral, but I haven't come across any evidence that it's affecting animals in the Arctic. But the loss of sea ice is affecting life in the Arctic. Most iconic species, the polar bear, is losing its hunting grounds. So traditionally would be hunting for seals on sea ice, and so those are going, and that's going to add additional pressure to those animals. Also, what you'll find on sea ice, it's got lots of holes that go through it as the salt is pushed out as it forms, and algae grows in the bottom of the sea ice, and that releases bits of dead material and sugars down through the water in a process known as marine snow, because it looks like snow coming down through the water. And then animals that live on the bottom of the ocean, like sea urchins or starfish, eat all that. So with less sea ice, there's different animals are being affected. How do you measure sea level rising? And that's from Elsa and Louis. It's a really great question. You measure it really on tidal gauges. So where you measure high and low tide is a great way to measure how the average of the ocean is changing. So you might have seen, certainly on rivers, near the sea, you'll see, and even at the sea, you'll see these almost like big rulers beside the sea in harbors and that kind of place. And those are used to measure sea level rise. The complication is that the sea is not flat, so you might have somewhere where the sea level is going down and other places where the sea level is going up. You can also use satellites to measure the average sea level, but it's a very complex issue to get a global average. So not just as simple of having a ruler at the beach every day. So there's a lot of different measurements to take, but a great question from Elsa and Louis there. Is it just that animals or humans living in the Arctic struggling too because of sea level rising? And that's from Barrett's. I haven't heard of sea level rise affecting yet Arctic communities. What I have heard is that the ice changing has changed the horizon. I think that was from an Inuit community. The way that they see the world is changing because of warming. But I haven't come across evidence that sea level rise is affecting humans in the Arctic just yet. Great question here from Greater Essex Virtual School, 5S. Do you expect sea level rise to stay constant, or will it accelerate as we move forward? It's a very, so sea level rise is really caused by two issues. This is the Greater Essex Virtual School. It's caused by melting ice. Okay, so that's adding, it's like turning on the tap. And how much ice melts and then goes into the ocean, and we'll see what type of ice that is. That tap is predicting how these, especially these big ice sheets like Antarctica and Greenland, will behave in the future and modeling that. We are seeing that there is accelerated runoff coming, and flow and glacial surging, so more ice coming into the ocean from those areas. So it does seem to be accelerating. The other way in which the sea level will rise is by a process called thermal expansion. And those two words mean that if something is hotter, it gets bigger. Okay, so thermal expansion just means if it's hotter, it's bigger. And as the ocean warms, its volume, its size will increase. And so the level that it takes up against the land will go up. So there is evidence that sea level rise is increasing, but it's all about how fast it will happen in the future is trying to work out how these very complex systems are going to change into the future. Wow. Kirk Burton, first school, how deep are the glaciers? I don't know whether there is a photograph somewhere of an ice cavern, which we showed in a lesson a few days ago, but this we'll try and find it, but this will give you an idea. This glacier, just around the corner from here, is one that we have worked on for a couple of years. And we actually went inside the glacier, so I can tell you how thick that glacier is. The image, I think, is from yesterday's lesson. And it's about 100 meters thick. So we abseiled down into it about 40, 50 meters. So we had 40, 50 meters of ice above us when we went inside through a crack, and 40, 50 meters of ice below us. So these glaciers are about 100 meters thick. They vary, an ice sheet from 4.5 kilometers thick on Antarctica to glaciers just 100 meters deep, just behind me on Svalbard. That was from Kirk Burton First School. Liddington class at Normarsh Junior School. How much would sea level increase if one glacier melts? Liddington class, I'm going to have to say, depends how big the glacier is. But if all the ice on Antarctica were to melt, we would see about a 60-meter sea level rise. That is unlikely to happen for a very, very long time. And if all the ice on Greenland were to melt, we'd see about a 6-7 meter rise. Again, unlikely to happen for a long time, just because those are in very sort of cold parts of the world receiving little sunlight. From Bowmandale Primary School, we live very close to the mouth of the River Humber. Should we be worried about the future of our town? It's a really good question. So even if the sea level rise were to rise, say, I think it's sort of predicted maybe 40 centimeters by the end of the century, maybe up to a meter, worst case scenario by 2100. If you live in a pretty well off country, there are going to be protections that will be built. Even if it's worst case scenario, really everything goes wrong. And so, in London, there's the Thames Barrier, and there will be other ways to protect coastal cities in well-off countries from sea level rise. I think one of the two things to think about. First of all, is storm surges. So if the level's already a bit higher, if there's a storm, it's more likely to cause some damage. And the second thing to think about is not just people living in areas like close to the River Humber in the UK, but those communities around the world which may not be able to afford the level of flood defense, sea defense that might be built in better off countries. It's a great question. Parsons Green Prep would like to know, are the changes in sea levels irreversible? Well, as you probably sort of gathered, that there have been many changes in sea level over the past millions of years. So water rises, evaporates from the surface of the ocean, and then falls as snow, and which then formed into ice on both Greenland and the Antarctic. Okay, those two major icy stores on our planet. And so there's this constant evaporation, condensation, precipitation, and then melt, and then out again, and there's this constant cycle going round. Sometimes when there is an ice age, the sea level will go down because there's more of that water being stored as ice. As ice melts, so at the end of an ice age, at the end of the last glacial maximum, about 8,000 years ago, what you saw was a huge release of that stored ice into the ocean, and you saw a sea level rise of several meters over just over a century. So there's always been this cycle. I think what we're looking at now is that warming that we're experiencing through climate change, is that going to accelerate the melt? The warming of the ocean will also expand its volume, and will that drive a very fast amount of sea level rise. From Red Hill Preparatory School, who or what encouraged you to be a scientist? Really lovely question. I have to confess, I'm not a scientist. I have been very, very lucky in my career. I used to be a teacher, and then I got involved in working with polar and marine science expeditions and helping to communicate those to schools. So you don't have to be a scientist to work on science expeditions. In fact, we were having a discussion last week about the huge array of jobs that are involved in polar and marine science, from working on the ships, boat handling, climbing and mountaineering skills to help scientists get to inaccessible places, electricians, plumbers, vehicle maintenance, people who work in communications, filmmakers, photographers, educators. There's a whole range of careers. But I do it because they are absolutely amazing parts of the world. And I think as much as we can do to share them with a wider audience is really important. So I keep on doing it because I think this, especially this part of Svalbard for me, I've got a deep fondness for, and I think it's just one of the most special parts of the world. How much has the sea risen in the last year, and how much is sea level expected to rise in the next 50 years? And these are both from Elsa and Louis. The current level of, if I'm just trying to remember, the current level of sea level rise is about 3.5 millimeters a year, which is about sort of that much. And so it's going up quite slowly. It is looking like it's accelerating, but 3.5 millimeters, sorry, that adds up to about 1 centimeter each year. How that rate changes in the future, as I said, is quite complex. And so we're really trying to work out two things. How much heat is going to get into the ocean, how that's going to change its volume. And the second is how the major ice sheets are going to behave as we head into the latter half of this century. Here we go. Shayla from year 6. What is the best thing about the Arctic? Two things. Shayla, it's just so beautiful. You think of it as somewhere that's white, but you can see from the picture behind me, you get these sort of like blues and purples. Sometimes in the setting sun, you get some golds and pinks as well. So it's just stunningly beautiful place. If you're lucky and you're up there when there's night, you get the Aurora Borealis, the Northern Lights. And I have cried with just just been overwhelmed by the beauty of the place. So that for me is the best thing about the Arctic. And the second, actually, I'm going to have two things. The second best thing is the wonderful friendships that you make when you're working closely with people in very difficult and cold sort of environment. You do sort of bond when it's minus 30, minus 40, because you're all going through the same sort of hardship at the same time, but also trying to achieve the same goals. Rowan, Hi, Rowan. Rowan in year six. What happens if you don't eat enough calories? Rowan, you just get thinner. It's that simple. So, calories is a unit of energy. And so, normally, you need for an adult male, you need about 2,000 calories a day. Um, if you're in the Arctic, you get up to about 5,000 calories a day, just working at just out in the cold every day, just that extra sort of, almost double or over double your calories just to stay warm. So you're burning more to keep your body warm. And then if you're pulling a sled, if you're man hauling or woman hauling, as it should be sort of, better known, you then burn so many more calories. So if you're doing one of those sort of traditional sort of sled pulling, um, expeditions, 9,000 calories a day. This is from Shrewsbury Cathedral Catholic Primary. Do you think our human population will reduce because of rising sea levels? It's a really interesting question. I don't think there's a definitive answer to it. I think, first of all, that we live near to the coast in lots of places. Traditionally, it's been great for trade and access to resources, so that's been good. But I think mostly it won't necessarily the reduction, but the movement of people. So if you, I don't know whether you ever touch on migration and the movement of people in geography, but maybe you think if you got a world map, and I think you can find, I think Nat Geo did some world maps of what the world would look like with various levels of sea level rise. You can look at that and then see how many people would be displaced and have to move on. What is the main factor of seas rising? Great question. So it used to be thermal expansion, and now in the past few years, the main factor is in fact melting of ice. And I think we've just in a couple of minutes, I'm just going to grab the ice and see whether our predictions are true. I'm just going to do a little bit of a sort of quick fire round with some of these questions. What happens to the animals as the sea levels rise? Not too much. We've covered the impact of melting ice in the Arctic on some of the other animals there. Has your base ever been flooded by sea levels? No. We've lived on the sea ice, so more concerned about there being cracks in the sea ice rather than sea level rising. How do you get reception in the Arctic, and how do you communicate with people who aren't in the Arctic? We're very lucky the base has fiber optic broadband, and that's mainly to transmit a lot of the important science data back to institutes and science organizations around the world. St. John's Primary, have you discovered, how can you tell what time it is when the sun doesn't rise? Just wear a watch. But in terms of your daily rhythm, it is quite confusing because we're sort of programmed for this daily rhythm. The sun comes up, we feel awake, the sun goes down, we go to sleep. So in the winter with 24 hours darkness, or in the summer with 24 hours daylight, you have to be really firm with yourself. Use lights, use meal times, use blackout blinds in the summer, just to try and keep on an ordered system of a day. Otherwise, you might just hibernate in the winter or try and work all night in the summer, which just throws the rhythm of the station right out, because you've got lots of different people and you all want to be on the same type of routine. So I'm just going to answer one more question, then grab the oceans. Do I prefer the winter or the summer? I really like spring. So you get some darkness, you get some sunlight, but in the spring, if you get the darkness, you get to see the aurora, which is truly, truly special. Now, I'm going to go and just grab the mini oceans, and we'll see if your predictions are right. And then we've probably got time for one or two last questions. So while I'm doing that, just vote on the two questions you want answered, and we'll have a look at the poll as well. So we are just going to look at the sea level rise. I'm just looking to get the camera in focus so you can see my line. The first one I've got up is, we're not getting any focus here. Maybe we have steamed right up because of the hot temperatures during Arctic Live. Okay. So the first one I've got up is what I've got is this one here is the sea ice. All our sea ice has melted, and we can see here that it has had no effect on sea level rise. So for all of you who thought that it's land ice or both in your terms of your predictions, let's just have a look at your predictions. That is somewhere we're going to get. So sea level rise in both, that was most of you. That didn't quite happen. We'll just come to the second ocean, and then I'll have a brief discussion about why this might be the case. So where are we on this one? Let's get, here we go. So we can see here with the land ice, we can see there's been a slight, we've still got a bit of ice on top, but there's a slight sea level rise. Now, just to go over this, so when we've had sea ice, the sea ice is formed by the sea freezing and then thawing. So there's no actual extra sort of volume being added. When you have ice on land melting, you're actually adding additional water, which had been stored as ice, into the ocean. So only the land ice sea level will rise is the correct answer. So just to look at those two, on this one we have the sort of Antarctic ice sheet or the Greenland ice sheet adding to sea level rise. But when you have the sea ice, that huge, great mass of ice freezing in the winter, whether that's the winter, our winter, or the austral winter in the southern hemisphere, and then contracting in the summer. So I'm just going to see if we've got a chance for one or two last questions, and then very sadly, it will be goodbye from us. The two top questions are, have you ever had a snowball fight in the Arctic? Yes, I have. It's absolutely fantastic. Really, really good fun. Of course, there's a little bit of time for fun during an expedition. And from W.H. Ballard in Canada, when will you be returning to the Arctic? As soon as possible, I hope. So we've really been stuck, like many people around the world, because of COVID restrictions. But fingers crossed, we'll be back in the Arctic either later this year or for the science season next spring, summer. Thank you all so much for being part of AXA Arctic Live and for taking part in the sea level rise live lesson, and hope you've learned a little bit more about ice. And thank you so much for all your brilliant questions. Do join us tomorrow when we will be joined by Dr. Helen Finlay, and we'll be looking at changes in the Arctic Ocean, and specifically changes in chemistry and how that is happening. But for now, it's a goodbye from Arctic Live. Bye-bye.